What else do we have over here? Computers again. Computer power supply. I'm sure you've all had a power supply fall apart or die or break. And if you haven't taken it apart, you don't know what you're missing. They're amazing devices. When they first came out with power supplies, one of the ways they made power was to run it through a transformer. And the transformer that it would take to do this job, I don't know, it had to weigh 20, 30 pounds. When I used to deal with power supplies that would do this kind of work for video games, they were heavy, amazingly heavy. So there's an amazing growth of what's happened in here for power supplies. And once again, you need to find how they work. You need to get in and take them apart. Taking them apart aggressively, learning how the insides come apart, is a good way to start realizing what it takes to dismantle something. If you haven't taken the time to actually take something apart, to actually break it, then you don't know how to put it back together again. So you've got to take the time, like a medical examiner, if you will, and learn how to take something apart. Take apart the stuff you don't care about. Wreck it. Learn how to get into it. And find out what it's made out of. Here we got the cooling fan. Real straightforward, very simple little device. How the heck would you get that apart? And see, learning how to take this apart, when you finally get around to one you want to try to fix, you'll have enough experience under your belt that you won't have to take it apart with a sledgehammer, which, granted, is a lot of fun. And pulling on this is causing the propellers to break. So that's not going to be a way to fix the one you want to keep. There we go. So I'm learning right now what it takes to break this and how hard I can push something before it'll bust. And if you're working on something you want to keep, that's a really good thing to know. All right, so this is part of your learning curve. Look at that. You wonder why they die. Look at the amount of dust and dirt that's on that thing. That is just unbelievable. But once again, there's a series of magnets in here. It's a standard DC motor. Most of these are usually 12 volts. Here it comes. Ooh, it's in there. I know it's in there. Ha! Got to be a way to get this out. You can see it. There's 4 windings inside of this that are actually allowing this to run and to work. All right, we're going in. Well, we'll look at that part later. Hey, all right. It returns. Ooh, cool. You see, this is a good thing to be taken apart. This is something that's full of just interesting pieces. Gets you inside. That is amazing how much stuff is in here. There's a little circuit board that I've ripped out of here. There's 4 actual coils inside of it. There's an outside housing. And this is all just to make a little cooling fan run. I mean, there's a lot to the inside of just the cooling fan in a computer power supply. Let's see, what else do we have in here that's interesting? Now, one of the things about computer power supplies is the capacitors. If you find yourself actually touching the circuit board of one of these, you can actually get shocked every now and then. So I'd be a little bit cautious taking these apart. Don't put your hands all over the back of this. There is more interesting stuff to dismantle. More transfer. That right there is the smaller transformer that I was talking about. There's actually a couple of them here. You have a small transformer here, you have a small transformer there, and you have another small transformer over here. Here, we have an actual transformer. This just turns one voltage into another voltage, and it really does it at a very limited amount of amps. If I was to actually get a calculator, I could figure it out. It's 300 VA, which is not a lot. And it weighs a ton, okay? This does less work than this. This will create several different voltages. It creates a clock pulse. It creates a lot of stuff it takes to keep your computer operating. This just changes one voltage into another voltage. Because of the electronic switching power supply, the ability to take the AC in, turn it into DC, and then run it through a small transformer at a very high frequency will then allow you to be able to bring it through a much smaller transformer and turn it into much better voltages. All right, now let's check out something a little bit more complicated. This is something you find in everybody's house. This is actually a GFCI outlet. And the outlet itself, is what it does is it actually monitors the electricity that's going out to the piece of equipment, going through the piece of equipment, coming back. And as long as they're the same, the GFCI will actually operate. Now this has electronics in it, one of the miniature transformers that we were talking about from power supplies. It has just about everything you could ever possibly imagine actually inside of the switch. Now we're going to have to take this apart. This is one of those one-way trips. It doesn't go back together again. It's got a bunch of little pieces over here which have been melted over to help hold this together, which I'm in the process of slowly removing. And here we go. And there we go. Another one. Another one. And another one. And we got some clips that actually hold this together. So we're going to need to take and get these clips to loosen up. Oh, and no glue. Look at that. It's going to come right apart. All right. Over here. And we get in here, and we have actual buttons that actually run the test switch. Another set over here. And let's, how's this come apart? How's this come apart? I don't see it. The back comes off. There we go. Look at that. And look, I got a pile of electronics inside this thing. There is all kinds of equipment in here. This is actually the little relay which opens and closes to disconnect your power. I mean, this is all so we can run a slightly, there's your relay, which actually allows it to let go. You have your electronics. No, this is not a circuit breaker. No, this does not even form a circuit breaker. This actually has nothing to do with current flow. This actually just monitors the power that's traveling through the current. And as long as it's going out and coming back the same, this will stay engaged. The circuit breaker in your panel is actually what's monitoring the amps, and that part is what will actually trip if you go over the amount of current that you're dealing with. So this is what it takes to monitor our electricity and make sure that it's all going where it's supposed to go. That's what a GFCI does. If electricity actually goes somewhere it's not supposed to go, it senses it and turns it off. But there is an amazing amount of stuff just packed into this little itty-bitty box. We've got chips, we've got relays, we've got sensors, we've got yokes and contact plates. We have, I mean, it's relatively amazing what is inside of this stuff. And if you have some of this stuff break or die around your home, then you actually need to go and give it an autopsy. Take it apart. See what makes it work. It's fascinating stuff. Learn as much as you can out there. All right, I'm getting someone snickering behind the cameras again. All right. Now, let's check something else out. Wait a second. Tools over here. Tools over here. No tools. Spare parts over there. Anyways. Here we have what's called ballast.